Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache PouchDB. PouchDB is a JavaScript database that allows you to store data directly in the browser. It's designed from the ground up for offline-first applications, meaning your app continues to function even when the user loses internet connectivity. One of its most powerful features is its ability to sync seamlessly with remote CouchDB-compatible servers, making it perfect for progressive web apps and mobile web solutions. So what sets PouchDB apart from other client-side databases? First, it runs entirely in the browser, leveraging modern storage mechanisms like IndexedDB and WebSQL. It's built for offline-first scenarios, ensuring that users can interact with your application even without an internet connection. It also supports bidirectional synchronization with CouchDB, giving you powerful data consistency options. Plus, being schemaless, it's flexible enough to adapt to changing data needs. Let's look at the core concepts of PouchDB. Databases in PouchDB are typically created per user or session, providing isolated data environments. Data is stored as JSON documents, each with a unique ID. Replication is the mechanism that handles synchronization between local and remote databases. Conflicts are managed using revision trees, and change feeds allow real-time updates to be pushed or pulled dynamically. Understanding PouchDB's architecture is key to leveraging its full power. It runs directly in the browser, using IndexedDB or WebSQL under the hood. Communication with remote CouchDB instances happens over HTTP, using a replication protocol that ensures eventual consistency. This local-first design guarantees offline capability while still allowing seamless sync once connectivity is restored. Getting started with PouchDB is straightforward. You can include it via CDN or install it using npm. Once included, creating a new database is as simple as instantiating the PouchDB class. Performing basic CRUD operations, create, read, update, delete, is intuitive, and you can use either promises or async await for handling asynchronous control flow. Always remember to handle errors gracefully to ensure a smooth user experience. Now let's take a deep dive into PouchDB's CRUD operations. The put method is used to create or update documents, while get retrieves documents by their unique ID. For fetching multiple documents, allDocs is your go-to method. Removing documents is done via remove, and for batch operations, bulkdocs offers efficient handling. These methods form the backbone of most PouchDB applications. One of PouchDB's unique features is its handling of document revisions. Every document has a revision ID stored in the rev field. Revision trees track the history of changes, which is especially useful in offline-first scenarios where conflicts can arise from concurrent edits. You can resolve these conflicts manually or let PouchDB handle them automatically, depending on your use case. Replication is at the heart of PouchDB's functionality. You can replicate data from local to remote, or vice versa, and choose between continuous or one-shot replication modes. Filtering changes during sync allows for more control over what data is transferred. Security considerations like authentication must also be handled carefully, and conflict resolution during sync ensures data consistency across devices. PouchDB's change feeds allow you to listen for real-time updates without the need for constant polling. This is done using the changes method, which emits events whenever documents are added, updated, or deleted. It's particularly useful for collaborative applications where users need to see changes instantly. You can also filter these changes based on specific criteria and combine them with replication for a robust synchronization strategy. Querying data in PouchDB is done primarily through MapReduce views. Map functions define how data is indexed, while reduce functions aggregate results for efficient querying. These views are materialized, meaning they're pre-computed for performance. While MapReduce is powerful, PouchDB also supports Mango queries since version 5.4, offering a more familiar SQL-like syntax for those who prefer it. Mango queries bring a more modern approach to querying in PouchDB. With a SQL-like syntax, they're more intuitive for developers coming from relational databases. Mango uses indexes for performance, supports sorting and pagination, and was introduced in PouchDB version 5.4. This makes it easier to perform complex queries without needing to understand the intricacies of MapReduce. For more advanced use cases, PouchDB offers several replication strategies. Continuous replication keeps your data in sync in real time. Filtered replication lets you sync only the data that meets specific criteria. Batched replication improves efficiency when dealing with large datasets, and checkpoints allow replication to resume from where it left off. Handling large datasets often involves pagination to avoid overwhelming the client or server. Security is a critical consideration when using PouchDB. While PouchDB itself runs in the browser, it communicates with remote CouchDB servers that must implement proper authentication and access control. Sensitive data should be encrypted before being stored, and document updates should be validated both client-side and server-side. Always use HTTPS to ensure secure transport of data. Optimizing PouchDB performance involves several best practices. Use indexes to speed up queries, batch operations to reduce overhead, and keep document sizes small to improve efficiency. Periodically cleaning up old revisions helps manage storage, and monitoring browser storage usage ensures your app doesn't hit limits imposed by the browser. Let's explore a real-world use case, an offline notes app. Users can create, edit, and delete notes locally in the browser, even without internet. These changes are synced with a remote CouchDB server when connectivity is restored. Conflict resolution ensures that concurrent edits don't cause data loss, and real-time updates keep all devices in sync. Another compelling use case is a task management system. Tasks are stored locally for offline access and synced with team members via a central CouchDB server. Real-time updates and notifications keep everyone informed, and conflict resolution ensures that task edits don't overwrite each other. The cross-platform compatibility of PouchDB makes it ideal for teams using different devices. Field data collection is another powerful application of PouchDB. Researchers or field workers can collect data offline, even in remote areas with no connectivity. Once back online, the data is synced with a central server. PouchDB handles large datasets efficiently, resolves conflicts from field edits, and ensures cross-device compatibility for seamless data collection. How does PouchDB compare with other databases? Compared to Dexie.js, PouchDB offers more than just an IndexedDB wrapper. It includes powerful sync capabilities. RxDB focuses on real-time and offline features but is more opinionated. Firebase is proprietary while PouchDB is open source. Local forage is simpler but lacks advanced features. And remember, PouchDB is the client-side counterpart to CouchDB, which runs on the server. Let's summarize the pros and cons of PouchDB. Its offline-first design is a major advantage, especially for mobile and web apps. Replication with CouchDB is seamless, and its schemaless structure offers flexibility. However, querying is more limited compared to SQL databases, and browser storage limitations can be a constraint for large datasets. PouchDB is ideal for offline-first web applications, progressive web apps, and mobile web apps that require data sync. It's also a great choice for collaborative tools that need real-time updates and field data collection systems where connectivity is intermittent. If your application needs to work offline and sync later, PouchDB is likely the right tool for the job. However, PouchDB isn't suited for every scenario. If your application requires complex SQL queries, high-performance server-side databases, strict relational data models, large-scale analytics, or full-text search capabilities, you might want to consider alternatives. PouchDB shines in client-side scenarios, but server-side needs may call for more robust solutions. If you're looking to master PouchDB, here's a learning roadmap. Start by understanding browser storage APIs like IndexedDB and WebSQL. Then, learn the basics of CouchDB for remote sync. Next, implement basic CRUD operations in PouchDB, explore advanced replication strategies, and finally, build a sample offline-first application to solidify your knowledge. To dive deeper into PouchDB, check out the official documentation, which is comprehensive and well-maintained. The GitHub repository includes plenty of examples to get you started. Community forums and Stack Overflow are great for troubleshooting. There are also tutorials and video courses available, and CouchDB compatibility guides if you're syncing with a remote server. When working with PouchDB, there are common pitfalls to avoid. Ignoring browser storage limits can lead to app crashes. Not handling conflicts properly can cause data loss. Overlooking security considerations can expose sensitive data. Using inefficient queries can slow down your app, and neglecting performance optimization can lead to poor user experience. Stay mindful of these issues to build robust applications. For production use, follow these best practices. Always use HTTPS for secure communication between the client and server. Implement proper authentication to protect your data. Monitor storage usage regularly to avoid hitting browser limits. Clean up old revisions periodically to keep the database efficient. And finally, test offline scenarios thoroughly to ensure a seamless user experience. PouchDB's ecosystem includes several useful plugins and extensions. The authentication plugin simplifies user management. PouchDB Find enables Mango queries for modern querying. PouchDB Upsert allows atomic updates, and Replication Stream can be used for backup purposes. You can even create custom plugins to meet specific needs in your application. Debugging PouchDB applications involves using browser developer tools to inspect databases and network requests. Enable PouchDB's debug mode for detailed logs. Check network requests to troubleshoot sync issues. Review conflict resolution logs for data inconsistencies. And monitor performance using available tools to ensure optimal operation. Testing PouchDB applications requires specific strategies. Mock IndexedDB for unit tests to isolate database logic. Simulate offline scenarios to ensure your app behaves correctly without connectivity. Test sync behavior under load to identify bottlenecks. Validate conflict resolution logic to prevent data loss. And use end-to-end testing tools to verify the entire workflow. PouchDB has a vibrant community and ecosystem. The GitHub repository is actively maintained, and there are numerous plugins and third-party tools available. Tutorials and learning resources abound, and forums like Stack Overflow offer community support. Integration with modern frameworks like React, Vue, and Angular makes it versatile for contemporary web development. Looking ahead, PouchDB's future is bright. It will continue to support offline-first applications as web development evolves. Improvements in browser storage APIs will enhance its capabilities. Better integration with modern frameworks, enhanced querying options, and a focus on performance and scalability are all on the roadmap for future versions. Let's look at a real-world case study. A company built an app using PouchDB and CouchDB to support field workers who needed offline functionality. They implemented a sync strategy with robust conflict resolution, applied performance optimizations, and learned valuable lessons about best practices in offline-first development. This case study highlights the power and flexibility of PouchDB in production environments. Performance benchmarks are essential for understanding PouchDB's capabilities. Query speed generally scales with document count, and sync performance depends on network conditions. Storage efficiency in browsers is good, but has limits. Compared to other client-side databases, PouchDB offers a balanced mix of features and performance. Indexing strategies can significantly impact query performance. When working with PouchDB, you may encounter common errors. Database open errors can occur due to browser issues or corruption. Sync conflicts need careful resolution to avoid data loss. Storage quota exceeded errors happen when browser limits are hit. Network timeouts during sync can disrupt data consistency, and invalid document structures can cause unexpected behavior. Understanding these errors helps in building resilient applications. If you're migrating to or from PouchDB, consider these strategies. Migrating from older versions requires careful handling of deprecated APIs. Switching from other databases involves data format compatibility checks. Handling breaking changes in new versions is crucial, and testing migration paths ensures a smooth transition. Proper planning can save significant time and effort. Integrating PouchDB with modern frameworks enhances its usability. React hooks can manage PouchDB state efficiently. Vue.js composables simplify sync logic. Angular services provide structured data management. State management libraries like Redux or Vuex can help manage complex data flows. Server-side rendering requires special considerations to ensure compatibility. To wrap up, PouchDB is a powerful tool for building offline-first web applications. It syncs seamlessly with CouchDB, making it ideal for PWAs and mobile web apps. However, it requires careful handling of conflicts, and both performance and security are critical in production environments. With the right strategies, PouchDB can be a game changer for your web development projects. Thanks for watching this deep dive into Apache PouchDB. If this video helped you understand how to build offline-first applications, hit that like button. Subscribe for more tutorials on modern web technologies, and don't forget to comment with your questions or share this with fellow developers. Check the description for additional resources and links to get started with PouchDB today. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.